Hey guys, so week 7, right? We're gonna start this week with something that we're pretty familiar with. At least we're familiar with the basic concept of it, and now we're just gonna create a little bit of a difference with it, right? So what we're used to, we've seen rationalizing the denominator, right? When we have a fraction with a square root symbol in the denominator, we know how to rationalize that. We know how to get rid of that. Remember, we never want a radical in the denominator. But so we're going to take that, we're going to review that a little bit, and then we're going to talk about how to get rid of a cube root in the denominator, and then how to get rid of a binomial with the square root in it down here, right? So that's going to be a little bit different. It's kind of the same basic concept. You're still going to have to multiply by a form of 1 like we do up here, but it is going to change just a little bit. So just to get us started here, let's do this review, right? So this 5 over square root of 3. So we know we got to get rid of that square root of 3 in the denominator. We know we have to multiply by a variation of 1, and that variation is going to be what the denominator is equal to, right? So we have to, forgot to do this. Okay. So we got to multiply by the square root of 3 over the square root of 3. Remember, square root of 3 over square root of 3 is just equal to 1, so we're not changing the value of this fraction. All we're changing here is how it's going to look. So when we get that, right, it's going to be, hang on just a second. So that top, you just multiply across. So we have 5 square root of 3 on top. And on the bottom, remember, if it's the same type of root symbol, so these are both square roots, we can just multiply the insides and keep it under the same square root. So 3 times 3 is 9, so we've got the square root of 9 on the bottom there. And that will cancel out. The square root of 9 is 3. So I'm going to write that down here. 5 square root of 3 over 3, because this guy's equal to 3. That's my final answer. That's the whole reason why we multiply by that square root of 3 symbol again, because the square root of 3 times the square root of 3, those radicals will cancel out and we'll just end up with 3. So that's our final answer there, right? So we just multiply by the denominator, make that a fraction of 1 right here, the square root, hang on, right here. So we make that, this is not happening for me. Okay, there we go. So we make that square root of 3 from the denominator a variation of 1, multiply across. It'll simplify down to this, and that's our simplest form right here, right? So let's continue to down over here. 3 over square root of 6. It's going to be the same exact process, right? Same exact thing. So I've got to get rid of that square root of 6 in the denominator, so I'm going to multiply this by square root of 6 over square root of 6. Again, it's just 1. We're not changing the value of this, just the way it looks. So that's going to simplify down to 3 square roots of, hang on, square roots of 6 over, and then I'll continue to do it the long way. So 6 times 6 is 36, so I have the square root of 36 in the denominator. And then the square root of 36 is 6. But this isn't completely simplified, right? Now I can simplify this bit right here. So I have 3 over 6. That'll simplify down to 1 over 2. So I can just write square root of 6 over 2, and that's my final answer, right? Always simplify the most you can. Okay, and then finally we have this over here, 3 square roots of 8 over square root of 2. And again, it's going to be the same stuff here. We got to get rid of that denominator, so I'm going to multiply it over here, square root of 2 over square root of 2. I'm going to multiply across. This time I have a radical in the numerator as well, so I've got to simplify that as much as possible. So I multiply across, the 3 stays, and then the square root of 8 times the square root of 2 is going to be the square root of 16. And the denominator, square root of 2 times square root of 2 is square root of 4. And then I have, actually I know the values of square root of 16 and the square root of 4, so I'm going to put those in. So I have 3 times square root of 16 is 4. Square root of 2, square root of 4 is 2. Then I'm going to simplify that down to it being 12 over 2, which is equal to 6. All right, so that one had a little bit more simplifying, but the concept is the same. Right? So hopefully you see that. Hopefully that makes sense there. That's some old stuff that you learned probably in like Algebra 1, I'm pretty sure. So hopefully that quick refresher got you to remembering that. Because what we're going to do now is going to be just a little bit different. It's not going to be the same exact thing. So what you need for this for your homework and for this workout or for this worksheet is going to be these perfect cubes. Okay, so write them down, memorize as many as you can because they'll come in handy. At least memorize 1 through 5. So like on SATs, ACTs, that kind of stuff, these are going to be really prominent. 1 through 5, the cubes of 1 through 5. So I'd have those memorized. Memorize more if you can. That'll even help you out even more. But for non-calculator sections of SATs and stuff like that, standardized testing, they're going to want you to have 1 through 5 memorized. So definitely have those memorized. So let's continue on to the new stuff, right? So I'm going to get rid of that circle really quick. And so simplify so that there is no longer a radical in the denominator here, right? So it's really asking you to do the same thing as on top, but now we have a cube root, so it's going to change a little bit. The process is going to change. So you're going to need these perfect cubes to really help us out here. So instead of multiplying this by what you would expect it to just be the same thing, right? You'd expect it to just be the cube root of 32 over the cube root of 32. That's not exactly what we want to do. If you were to do that out, the cube root of 32 times 32 is not going to be a pretty number, right? Because it's not squared anymore. Squaring a square root cancels it out. Squaring a cube root is not going to do anything, right? That's not going to do anything for us. So what we have to do here is look at our perfect cubes and see which one is going to match, or which one we can get to the fastest. So what can I multiply 32 by to get it to look like one of these, right? Is it that one? Is it that one? Is it that one? Right? Looks like I can do that really nicely. 32 times what gives me 64, right? I can just multiply 32 times 2. That'll get me 64. So it takes a little bit of cleverness, takes a little bit of, looking at that, and it's going to take me forever. Hold on. I had to go ahead and erase all that. So that's going to make it a little bit easier. So seeing what you can multiply by 32 to get to the next perfect cube is going to make your life a lot easier. So as we said, 32 times 2 gets me to this 64 up here, which is a perfect cube, right? So that's exactly what I'm going to do. I'm going to come down here and I'm going to say, okay, I'm going to multiply this by the cube root of 2 over the cube root of 2. And so what's going to happen here is I'm going to multiply across, and so I'm going to get the cube root of 22 over the cube root of 64. Now, again, the cube root of 64, that's a perfect cube. That's right up here, right? That's right up here. That's sitting at me, staring at me right here. So I can simplify that very easily. So I can come back down here and say, okay, well, I don't know what the cube root of 22 is, so I'm just going to rewrite that. Remember, we can have a radical in the numerator, that's fine. But the cube root of 64 is going to be 4. That looks about as good as it gets, as simplified as it gets. So there's your answer. Right, so it is a little bit different way of thinking about it. It's very easy when you have these up here, these square roots, because all you do is take whatever is in the denominator and multiply it by that. Right, it's very easy, very straightforward. This takes a little bit more thinking, right? So you got to find what you multiply 32 by to get to the next perfect square. Oh, I see that 32 times 2 is 64, so I'm going to multiply by that. Get my perfect, I'm sorry, I said perfect square, perfect cubed, right? So I'm going to multiply 32 times 2 to get me the next perfect cube. And whatever that perfect cube is going to simplify down to, right? So let's go on and see for number 2, right? So we have the cube root of 27 over 81, right? Remember, when I have the cube root of a fraction, a whole fraction like that, I can always simplify it by putting that cube root to the top and the bottom, right? So I have, really what I have here is the cube root of 27 over the cube root of 81. Right, now, I know the cube root of 27 is 3, so that's really nice, but that doesn't help me with my denominator. I need to radicalize that denominator, rationalize that denominator. So what can I multiply by? So the big numbers is where it can get a little bit tricky, right? You can sit here and go through, I'm sorry I keep zooming out and going up, but you can sit here and go through and ask yourself, okay, 81 times what? So you can sit here and say, okay, 125 is bigger than 81, so does 81 go into that evenly? Probably not. Right? What about 216? What about 343? What about, and you can keep going like that, and that's perfectly fine. You can do that until you grow old. But I noticed that 81 The square root of 81 is 9, so really 9 times 9 is 81. If I multiply by another 9, I'm going to get this perfect cube up here. 81 times 9 should give me 729, right? So that's what I'm going to do. I'm going to say, okay, if I multiply another 9 to that, it's going to get me a perfect cube, so that's what I'm going to use. Cube root of 9 over the cube root of 9, right? So then I'm going to multiply across, and I get 3 times the cube root of 9 over the cube root of 729, and I know the cube root of 729 is 9, so that's going to be my answer here. So the top, my numerator is going to have 3 times the cube root of 9 over 9. And then again, I see that this fraction, these whole numbers in the fraction can simplify down to 1/3. So that's exactly what I'm going to simplify down to. So I have the cube root of 9 over 3. And that's my final answer. Right? Not too bad. Not too bad. Okay. So now on to number 3. Uh-oh. There you go. So on to number 3. This is going to be a little bit different. Notice this is just a regular old square root symbol. Right? Nothing different about that. It's just a regular old square root symbol, except I'm going to add something to it. It's not just the square root of 5. It's 2 plus the square root of 5. So going from our old ways, right, when we have a square root symbol in the denominator, it's as easy as taking that denominator and multiplying it by itself. Right? So let's try that. So I'm going to multiply by 2 plus the square root of 5 over 2 plus the square root of 5. And I'm going to see how this works out. Okay? So the top is just going to multiply across to be itself, so that I'm not worried about. But the bottom, I've got a FOIL. And now I'm going to, just for note's sake, I'm going to go through that pretty quickly. So first, outside, inside, last. First is 2 times 2 is 4. Outside is 2 square roots of 5. Inside is also 2 square roots of 5. 5. And the last is going to be square root of 5 times square root of 5. That's going to be 5. So now I can simplify that down. So really what I have here is 2 plus the square root of 5 in the numerator still. But the bottom, 4 plus 5 is 9. And 2 square roots of 5 plus 2 square roots of 5 is 4 square roots of 5. Now that doesn't help me. That didn't get rid of the denominator. I'm sorry, that didn't get rid of the radical in the denominator. So that didn't help me at all. If anything, I just made my life more complicated. Right? So let's go ahead and try this again. But we've got to change up what we're dividing by. And I'm going to pause it real quick so I can erase all this. So again, we got to change what we're dividing by here. And normally we would sit here and try out everything and make sure we were getting a good understanding of why this is happening. But for time's sake, I'm going to tell you we take the opposite of our radical. So instead of multiplying by 2 plus square root of 5 over 2 plus square root of 5, it's going to be 2 minus square root of 5 over 2 minus square root of 5. And for that reason, you're going to see here in a second. So when I multiply across, the top, again, is going to remain the same. Nothing changes in the top. But when I FOIL the bottom, you're going to see why this is going to be essential here. So my first is still going to be 4. 2 times 2 is 4. Outside is going to be negative 2 square roots of 5. Inside is going to be positive 2 square roots of 5. And if you're real clever, you see why that negative has to be there. Because now, yes, 4 plus 5 is still 9. So let me write this numerator again. So this is this simplified. So 4 plus 5 is still 9. But now I see... let's get red here. So when I combine these two, negative 2 square roots of 5 and positive 2 square roots of 5, that's going to cancel out to be 0. So these are going to cancel out, and I just have the 9 in the denominator. So let's go ahead and center this. Oops. There we go. Let's go ahead and center that. So that's what that will boil down to, and that's my final answer. That's completely simplified for me. Right? So note that what's happening here is I take this denominator, but I make the radical opposite. So 2 plus square roots of 5 is the denominator here, but I'm going to go ahead and change the sign of the radical, so I have 2 minus square root of 5. Right? And then I just FOIL that out. That'll get rid of my square roots. Then I've got a nice little simplified fraction right here. Right? It's rationalized. The denominator's been rationalized. Right, so let's go ahead and see if we've learned that with this last one, number 4. So again, you want to take the opposite of the radical, right? Opposite of the radical. So when I come here, the opposite of the radical is negative right now, so I want to multiply by a positive radical. So that's going to be 4 plus square root of 6 over 4 plus square root of 6. Right? So again, when we multiply that out, multiply across, the top will remain the same because it's still a 1 up there. And the denominator I'm going to FOIL out. First, 4 times 4 is 16. Outside is positive 4 square roots of 6. Inside is negative 4 square roots of 6. And last is going to be negative 6. Uh-oh. I definitely messed up the one before. So we're going to go back to that here in a little bit. Hopefully you caught that, and hopefully you were yelling at your screen when I made this mistake. But let's continue to finish this one, and then I'll go back, right? So I have 4 over the square root of 6. So I'm going to rewrite that. So the numerator is going to stay the same. 4 plus square root of 6. Denominator is going to simplify. 16 minus 6 is going to be 10. And then this positive 4 square root of 6, negative 4 square root of 6 is going to cancel out, which is exactly what we want to happen. And then we've got our answer right here. This is the simplified version, right? Very simple, very straightforward, right? Before I end the video and recap a little bit, let's go back up here because I definitely made a mistake here. Last time I checked, the last of this FOIL here, positive square root of 5 times negative square root of 5 should give me a negative 5, not a positive 5. I caught that when I was doing that second problem. So I'm going to come back here, put a negative here, and then 4 minus 5 should be negative 1. So that should be, why is this working? That should be my denominator, that negative 1. And there you go. So let me rewrite this just for good measure. So my final answer is 2 minus square root of 5 over negative 1. Sorry about that mistake. Like I said, I hope you're yelling at your screen telling me I was a fool. I was a fool. Okay. So, yeah. So for all you worms out there, that's about it, right? So, basically just to recap just a little bit, quick recap, right? Up here, remember, you've got to find, with these cube roots in the denominator, you've got to find what you can multiply by to get to the next best perfect cube. So here we multiplied 32 times 2 to get 64, and that was a perfect cube, right? Same down here. We multiplied 81 times 9 to get 729, which is a perfect cube, right? And then down here, 3 and 4, those guys, we just take the opposite of the radical. So we start here with 2 plus square root of 5, and we just multiply it by 2 minus square root of 5. That will get rid of that radical, and that will rationalize our denominator. Same thing here. We had a negative square root of 6, so we multiplied by 4 plus square root of 6, and that got rid of our radicals, simplified it down to what we wanted it to be, right? So you guys just have 4 questions on big ideas, so just make sure you get those done. They're very similar to these questions, so if you have any questions, feel free to contact any of us, and we'll be happy to help, right? Hope you guys have a great week.